Hello, so this is A-Level Maths Tutor UK. In today's video, we're going to look at answering this question here, essentially, that I've written on the screen here. So let's say we've got two numbers, A and B, two real numbers. Can we write the sum of a number times sine plus a number times cos into one of these forms here? So some number, some positive number, r times sine of x plus alpha, where alpha is some other real number, and or the form r times cos of x plus alpha. So basically, if you've got something like, for example, as an example, 4 sine x plus 3 cos x, could we rewrite this into some kind of form r sine of x plus alpha, where alpha is some number that we need to determine, for example? So that's what we want to look at today. We want to look at, can we rewrite the sum? Well, technically we call it the linear combination of sine and cos. Can we find a way of rewriting the sum of this sine, some kind of sine function, plus this some kind of cosine function? Can we find a way of writing it in this form here, where we're just writing it in terms of a sine function and a cos function, which has been shifted across by some vector of a in the x direction and some stretch of r parallel to the y-axis? Can we rewrite it in this form? So, I mean, the answer to this question is yes, we can, and that's what we're going to do today. And the reason why this is useful is particularly useful when we want to find maximum and minimum values of this kind of function here, when we've got like the sum of sine and cos functions. It's quite useful for that kind of thing. So that's why we do it, why we tend to do this. So let's look at, or let's have a reminder of what we have in our formula book. So in our formula book, we've got these two formulas here. So the sum and the subtraction angle formulae for sine and cos. So we've got sine of a plus or minus b is equal to sine a times cos b plus or minus sine b times cos a. And we've got this one here. So cos of a plus or minus b is equal to cos a times cos b minus or plus sine a times sine b. So that's our formulae. So let's think about this this sine of x plus a that we wrote here, and this cos of x plus a. So let's substitute in x and alpha instead of the capital A and the capital B. So what we want to do here is just call the a x and the b alpha, and we're going to plug that into our two formulae. So with the first one, plugging the a into the first one, we get sine of x, and then b into that part there, we get cos of alpha. And then plus, or well, I mean, I'm just going to put a plus sign there. So alpha is just a real number, so it could be positive, it could be negative. I'm just going to take a plus sign there. So we'll just use the positive versions here of these. We'll just use the addition formulae. It won't really matter. I mean, you'll see at the end that it won't really matter too much. So we've got yeah, plus sign, and then sine b, but b is alpha, so we've got sine alpha, and then times by cos a, which in this case is cos x. And we can do a similar thing with the bottom here. So again, substitute in a for x, so we get cos x times by cos of b, which in this case we're calling alpha, and then subtract this time, because we've got a plus sign there, subtract sine of a, which is sine of x, and then sine of b, which is sine of, sorry, yeah, sine of alpha, because b is alpha. We're just substituting that in. Okay, so we get these two equations there. So I'll just kind of put like a box around these because these will be important. So we've rewritten essentially this part here and this part in terms of our subtraction and addition angle formulae from the formula book. So, okay, now let's use that. So what we've actually got, if we go back to the original slide, so we want to write this. Essentially, the objective of what we're trying to do in this video is we're trying to write this expression into this form here and into this form here. So we're going to multiply our result down here by r. So our two results there, we're going to multiply by a factor of r. So we're going to multiply that by r, and we're going to multiply that by r. So obviously what this means is that we multiply this entirety thing, this thing in entirety by r, and this thing there in entirety by r. So we're going to do that here, just multiply this all by r, and so that's going to give us an r sine x. For me, it's span the brackets, r sine x, r cos alpha, and then plus r sine alpha times cos x. And then what I'm going to do is I'm just going to rewrite this. So I'm going to write it like this. So I'm just going to rewrite the order of our multiplication. So we've got r cos alpha times by sine x, and then plus r sine alpha times by cos of x. So I'm just going to write it like that instead. And the reason why I'm doing that is kind of because of what we've got here. So again, it'll become clear why I'm doing it like this, why I'm kind of pulling the r cos alpha and the r sine alpha in brackets and writing the sine x on the outside and the cos x on the outside. Basically because we want to compare it to this thing here. That's kind of the objective. So again, we'll do the same thing. So we did that here with this r sine x plus alpha. We'll do the same with this r cos x plus alpha. So again, expanding the brackets, we get r cos x times cos alpha, and then subtract r sine x times by sine alpha. And again, I'm going to do a very similar thing to what I did here. I'm going to kind of box off the cos and the sine alphas and the r's. So we get an r cos alpha, and then times that by this cos x there, and then subtract this this bit here, this r sine alpha, and then times by this sine x at the end there. Okay, so we've got that all so far. So then what can we say from here? So we can say that if we compare, if we go back to our first kind of calculation here, we calculated this down there. So using this, using our result that we got here, let's compare that with this a sine x plus this b cos alpha. So if a sine x plus b cos x is equal to this thing up here, this sine x plus, sorry, this r sine x, I forgot the r there. So this r sine x plus alpha, which is this here. So if it's equal to this here, r cos alpha times by, let me do that again, sorry, times by sine x plus r sine alpha times by cos x. So if the this thing here, this linear combination of sine and cos, is equal to this kind of double angle sum addition formula for sine, then that means that this number here must be equal to this number there. You've got a sine x there and a sine x there. So these coefficients must be exactly the same. And it means that this coefficient there, this b there, must be exactly the same as this r sine alpha there, because you've got a cos x there and a cos x there. So by equating the coefficients, so therefore by equating coefficients, we can see that a is equal to r cos alpha and that b is equal to r sine alpha. So specifically when you've got r sine of x plus alpha, that means that if you want to write it, so if you've got this a sine x plus b cos x and you want to write this in this form here, it means that a must be equal to r cos alpha, and it means that b must be equal to r sine alpha. So that's what we've shown there to start with. Now let's do a similar calculation for cos. So with this formula, so with the cos x plus alpha formula that we calculated, so again, let's compare this with this a sine x plus this b cos x. So if a sine x, sorry, so if a sine x plus b cos x is to be equal to this here, again, I forgot the r here, so let me just put the r in here because this is a mistake. There should be an r there. So if this is equal to this, then again, I'll just write this out in full. So r cos alpha times by cos x, and then minus r sine alpha times by sine x. Then that tells us that if we look at this cos x and this cos x, the coefficient of this cos x is b. We've got to equate the coefficients. So this b must be equal to this r cos alpha there. And similarly with this here, we got a sine x there and a sine x there. So this A coefficient must be equal to the negative of r sine alpha. So we can say that therefore, again by equating coefficients, A is equal to minus r sine alpha. And we can say that B is equal to r cos alpha. So when we want to convert this thing, this kind of number times by sine plus this number times by cos into this format here, we know that this A there must be equal to minus r sine alpha, and B must be equal to a positive r cos alpha. But if we want to convert this kind of sum of sine and cos into this form with the r sine x plus alpha, then in that case, A is going to be r cos alpha and B is going to be r sine alpha. So it will depend on the question. So let's kind of summarize what we have then. So with this one here, when we want to convert the sum of sine x times by a multiple plus the cos x times by a multiple, and we want to write it in this form here, specifically when the question asks us to write it in this form with the sign there, that means that A is equal to r cos alpha and B is equal to r sine alpha as we got down here. So just copying this result again down here. So that means that B divided by A, I mean, let's look at B divided by A and see what happens. So B divided by A is r sine alpha divided by r cos alpha. So the r's cancel out there. You're then left with sine alpha over cos alpha. This is going to be tan alpha, because remember, sine over cos is tan. So this equals B over A. So therefore, we can say that alpha is going to be tan inverse of B over A. So we know that if you've got, again, a number times sine plus a number times cos, and you want to write it in this form here, we can say with certainty that this alpha that you need to add on is going to be the tan inverse of this number divided by that number. So that's what this formula there is telling us. Now let's look at what happens if we square this here and we square this here. So if we do a squared plus b squared, we get r cos alpha all squared plus r sine alpha all squared. Now this here is going to give us an r squared cos squared alpha. And this is going to give us an r squared sine squared alpha. We can factorize out an r squared. So we get r squared times cos squared alpha plus sine squared alpha. Now we know from another trig identity that cos squared plus sine squared is just equal to the number 1. So therefore, this is equal to r squared. So what is this telling us? So it's telling us that this r squared that we need to calculate. So we need to calculate r, we need to calculate alpha. We've calculated alpha there. But to calculate r, we know that r squared must be equal to a squared plus b squared. And so therefore, r is equal to the square root of a squared plus b squared. So that's our second result here. So what we can show, again, is that when we want to convert this sine x function plus this cos x function into the form a number times sine x plus alpha, it means that r must be the square root of this number squared plus this number squared, and this alpha must be the tan inverse of this number next to the cos divided by this number next to the sine. Okay, so we've worked that out. So let's now do a similar calculation when we want to write the sum of the sine of the cos function in terms of cos. So when we want to do this, what we again realize back on this page here is that when we did this, A was equal to minus r sine alpha, and this capital B was equal to r cos alpha. So we're going to do a very similar process here, very similar calculation. So we're going to do A divided by B. The r's will actually disappear here. So we're going to be left with sine over cos and a negative sign there. Just remember we've got the negative there as well. So we're going to get a negative tan alpha. Okay, so then that means that therefore tan alpha must be equal to the negative of A over B. And therefore we can do tan inverse on both sides. So therefore we can say that alpha must be equal to tan inverse of negative A over B. So, sorry, I forgot the minus sign in there. Let me do that again. I'm just going to try my best to move this to the side. Moving this to the side there. So, yeah, so the alpha angle is going to be negative A over b. So when specifically the question asks us to write the sum of a sine function plus a cos function in terms of cos only, then it means that this alpha there has to be equal to tan inverse of negative a divided by b. So we got that result. And now again, if we square a and we square the b, what do we get? So we get r times sine alpha all squared plus r times cos alpha all squared. So we're going to get an r squared sine squared alpha plus an r squared cos squared alpha. Again, very similar process to what we did before. We can actually just factorize out the r squared. And that's going to give us an r squared times sine squared alpha plus cos squared alpha. And we know that sine squared plus cos squared is just the number one from the trig identity. So this is r squared. So again, we get the same result as before. So r squared is equal to a squared plus b squared. So therefore, r is equal to, I actually forgot the minus sign here, so I just realized the a is negative r there. So there should be technically a minus sign there. But when you do minus r times minus r, you get positive r anyway. So actually, it doesn't really matter. But yeah, we're going to get r equals the square root of a squared plus b squared. So that's what we calculate when we want to transform the sum of a sine and a cos function into a function in terms of just cos. So let's look at a summary of what we just did then. So that means that a times sine x plus b times cos x is equal to the square root of a squared plus b squared times by sine of x plus tan inverse of b over a. So kind of using this result that we got down here. So when a sine x plus b cos x is equal to r sine x plus alpha, it means that alpha must be tan inverse of b over a. And it means that r must be the square root of a squared plus b squared. So we're just repeating this here in a summary. So we're just summarizing all this. So this is a fact. So it's a fact that a number times sine x plus a number times cos x is the square root of a squared plus b squared times by sine of x plus tan inverse of b over a. And this second fact down here, which we calculated or we worked out on the previous slide. So when you want to convert a sine x plus b cos x into the form r cos x plus alpha, it means r must be the square root of a squared plus b squared again, but it means that your alpha, your angle value that you add on, your kind of x transformation or x translation, is going to be tan inverse of negative a over b this time. So negative a over b. So you can actually use these formulas or memorize these formulas if you like to, when you've got to convert the sum of a sine function and a cos function into a function in terms of only sine or only cos. So, I mean, we'll do a brief example because, I mean, you don't really have to learn these formulas. I mean, if you do learn them, then that's good for you, but you don't have to because you can actually just use the same process that we did here, the same algebraic process, if you have numerical examples. So we'll do more of that in the next video, but we'll just do a brief example here. So let's say you've got in a question, r is greater than 0 and alpha is some real number. So let's say the question asks you to write 4 cos x minus 3 sine x into the form r cos of x plus alpha. So what we're going to do in this case is we're going to use the formula, the second formula down here that we found. So we know that r cos x plus alpha must be equal to this 4 cos x minus 3 sine x, because we're trying to rewrite this here into this form there. That's what the question's asking us to do. So we can use the cos formula. So we're trying to write this sum of this cos function and this sine function in terms of just cos. So we can use the cos formula that we got down here. So we know that this r is going to be the square root of a. So our a in this case is the number in front of sine. So I've called the a the number in front of sine. So let's just make a note of this, that our a in this question here is going to be negative 3. And our b in this question here is going to be 4, so the coefficient of cos. So we're going to have in our formula a squared, so minus 3 squared, plus b squared, 4 squared. So that's just going to be the square root of 9 plus 16, which is the square root of 25, which is 5. So we've calculated r. We know that r is equal to 5. And then to calculate alpha, again, that's using this formula here. So alpha is equal to tan inverse of a over b. So alpha, well, sorry, negative a over b, sorry. So tan inverse, so alpha is tan inverse of negative a over b. So that's going to be tan inverse of negative a. So negative 3 is actually just 3. And then over 4, which is the b. So we want to do tan inverse of 3 over 4. And the key thing to bear in mind is that this angle is in radians. So I should have probably mentioned this at the start, but the angle there must be in radians. So in these questions, you use radians with these questions. So then, yeah, you do that on the calculator. So tan inverse, I'll just make sure my calculator's in radian mode first of all. So you want to do tan inverse of 3 over 4, and that will get you 0.6435 radians to 4 significant figures. So 4 significant figures. So therefore, what we can say then is from this question, if we just move all the writing up, so therefore the conclusion from here is that 4 cos x minus 3 sine x is exactly the same as 5, so the r value times by cos of x plus 0.6435. So that's what this this example is telling us here. So using the formula that we derived here, and we could also do a similar thing with this formula here, but this question specifically asking us about converting into a cos function, we can derive this result. So 4 cos x take away 3 sine x is exactly the same as 5 times cos of x plus 0.6435. So that's just an example of how you can use these formulae. So yes, they will be important, especially in our next video. So in tomorrow's video, make sure you watch that video, because we're going to look at why you even want to do this stuff in the first place, because we've not really talked about today why you even need to do this in the first place. But yeah, tomorrow we're going to look at actually why this is useful, why writing something like this into this form here is actually much more useful than having this here just on its own. So it's much more useful to convert this kind of thing into just one function, one trig function, rather than a sum or a subtraction of 2 different trig functions. It's much easier to have this form here than this form here, and we'll see in tomorrow's video why that's the case. But today was just a summary of showing you that actually you can write the sum, the linear combination of sine and cos, of 2 sine and cos functions into the form, into a form whereby it's just in terms of sine, and into a form whereby it's just in terms of cos. So yeah, that concludes today's video.